Hey kiddos, today we are going to be talking about word problems. I know that's like everyone's favorite topic. So, one of the things that students usually say they need help with when we're talking about word problems is how do I read the problem and interpret what they're asking me to do? How do I actually know what I'm solving? Now, the key thing in math is that we are all problem solvers. It's not necessarily just about the numbers. Numbers are just the medium that we use to solve problems. But in math, it's all about approaching a problem and figuring out how you're going to come up with a solution. So that's what we're going to practice today. We are going to be going through these problems and looking at how we can um, figure out a procedure for solving them. Okay, so this is what I do. Whenever I have a word problem, I read it carefully multiple times. I identify what I'm actually trying to solve for. That's usually going to be our variable, and we're using x as our default. And then we're going to come up with a plan based on what you know. What are you given in the problem to help you solve for that value of x? Okay, so for each problem today, this is going to be our process. We're going to read the problem once. We're going to read the problem again, and then we're going to underline our given values, the things we're trying to find, maybe circle the thing that we're actually looking for. Then we're going to write an equation based on what we've underlined, and then we're going to solve that equation, making sure that once you solve, you actually answer the word problem. That's super important. Okay, so our first example are going to be some straightforward word problems where we're just interpreting what the word problem is saying and turning it into an equation. So this is pretty straightforward, although sometimes you do have to think a little backwards because the way that they give you information is presented not always linearly. Okay, so let's look at what that means. So here's our word problem. Jade spent $42 on her shoes. This was 14 less than twice what she spent on her dress. How much was the cost of her dress? So one thing I like to do is I like to separate the information based on the way that it's presented. So I cut them into sentences. So the first sentence, Jane spent $42 on her shoes. This is a definite value. So we know for sure that she spent $42 on her shoes. This was 14 less, and less usually means that we're subtracting something, than twice what she spent. So twice means we're going to be multiplying something by 2 that she spent on her dress. How much was the cost of her dress? Now, because the question is asking how much was the cost of her dress, this is our unknown value. So this is what we're going to call x. Okay? So to solve this problem, we need to generate an equation from this information. So we know that $42 is a definite value, and that is the same as, that's a coded way for saying equals, $14 less than twice what she spent on her dress. Now, this is where we got to kind of think backwards, right? So we're going to look at the dress part first. The dress is X. That's what we don't know. And this is saying it was 14 less than twice that. So if the dress is X, twice that would be 2X. And $14 less would be subtracting $14 from that amount. Now, what I like to do before I solve is I go and I read through the equation that I just created and see if it makes sense with the story from the word problem. So the cost of her shoes is $42. That's equal to twice what she spent on her dress, which I don't know how much that was, and then $14 less than that. So this equation jives exactly with what is in the word problem. So I can go ahead and solve this. We're just working backwards. So I'm going to add 14 to both sides. Again, trying to isolate x, so x is all by itself. 42 plus 14 is going to give me 56. 2x is left over on the right side, the 14's cancel, divide by 2. Now x is isolated, that's what I wanted, and 56 divided by 2 is going to give me 28. Now, it's always important once you solve for x that you put it into context and you actually answer the question that's being asked of you. The question from the word problem says, how much was the cost of her dress? And since her dress stands for X and X is 28, the dress was $28. Okay. And again, very important to always answer the question, put it into context, make sure it actually addresses what you're being asked. Okay. Example number 2 is going to be very similar. We're looking at a word problem. Now, this word problem is very gendered. It's from an old textbook, so normally I wouldn't assign something like this. It's a little behind the times. There are 27 boys in the math class. This number is 3 more than 4 times the number of girls. How many girls are in the class? So I've read through it once. Now I'm going to separate it based on sentences. There are 27 boys in the math class. That's a definite amount. I know that there are 27 boys based on the question or the word problem. The number of boys is 3 more. 3 more means we're actually going to be adding 3. Then 4 times, and again, 4 times means we're multiplying something by 4. I just don't know what it is yet. The number of girls. How many girls are in the class? Because the question is asking how many girls are in the class, girls is your unknown value. That's going to be your x. Okay, so let's set up our equation. 27 is our definite value. That's the number of boys. And that's equal to the number of boys is equal to 3 more than 4 times the number of girls. Because girls is x, we're going to do 4x, so 4 times the number of girls, and then 3 more than that means plus 3. Okay, again, let's read through our equation and make sure it makes sense. So the number of boys is equal to 4 times the number of girls, and then 3 more than that. Perfect. Now we're going to work backwards, so subtract 3 from both sides. 27 take away 3 gives you 24 on the left. 4x is going to come down, and the positive 3 and negative 3 cancel out. Now divide both sides by 4. On the right side, the 4's cancel. X is now isolated. That's what I wanted. 24 divided by 4 is going to give us 6. And now we have to put it into context. If X stands for the number of girls in the class and X is 6, then that means there are 6 girls in the class. Very small percentage of girls. Okay. Now we're going to pivot. We're going to be working on a different type of math problem next, a different type of word problem. The next type of word problem is going to be where we have 2 unknown values, but they're based on one another. So even though we have 2 x values in the problem, one is based on the other, and we're going to use that definition, one being based on the other, to actually find our 2 missing pieces. So our first example of this, on an algebra test, the highest grade was 42 points more than the lower grade. The sum of the 2 grades was 138. What was the lowest score? Okay, so on this problem, there are 2 tests that we're thinking about. On an algebra test, we have the highest grade was 42 points more than the lowest grade. So we have the highest grade, which I don't know, but it's 42 points more, so plus 42. Then the lowest grade, which again, I don't know. They're both unknown values. I do know that the highest grade was 42 points more than the lowest grade, but that doesn't mean I know what the highest score is. The sum is very important. Sum means we're going to add those 2 scores together and they're going to be equal. Okay, so sum of 2 grades was 138. So I know that I have 2 scores, right? I have my low score. I'm going to add that together with my high score. And together they equal 138. Now again, I don't know what either score is, so I'm going to put x's in for both of them. But that technically right now means they're the same score, and I know that's not true. I do have more information on the high grade. The highest score was 42 points more than the lowest, so I'm going to add 42 to the high score. Okay. Now let's see if this makes sense. The low score is x. The high score is 42 points more than that, so it's x plus 42. That's exactly what that means. And together, when I add them, they equal 138. So now I can combine like terms. I have 2 x's plus 42 is equal to 138. Okay. Now I'm going to solve this, same as I've been solving the other ones. I'm going to subtract 42 from both sides. Okay. When I subtract 42 from 138, I get 96. I'm going to divide by 2. And x equals 48. Okay. Now, again, I have to put this into context, because just because I have x doesn't mean I actually answered the question yet. So the question is, what was the lowest score? So the lowest score is X. It's represented by X. So because X is 48, the lowest score is 48. Okay, and then I've actually answered the question. Okay, let's go on to our next example. Going to be very similar to this one. In 1 hour, Jamie drove twice as far as Rhonda. Combined, they drove 90 miles. How many miles did Jamie drive? So this is the kind of problem, again, where you have two values you're not really sure of. There are two unknown factors in this problem. We also have this concept of time, but time in this problem doesn't matter. So in 1 hour, that doesn't mean anything to us. That's just a limiting factor. It's basically saying that they both drove the same amount of time, so you know that you can set things equal, right? One's not driving for longer than the other. So in 1 hour, Jamie drove twice as far as Rhonda. So Jamie is one of the unknowns, and they drove twice as far. So that's going to be multiplying something by 2 as Rhonda. And Rhonda's our other unknown. Combined, they drove 90 miles. So combined again is coded for equals, and it's 90 miles. How many miles did Jamie drive? So again, we can create a picture here. We have two unknown values. We have Jamie, and we're combining that with Rhonda. Combined, they drove 90 miles. So at this point, I don't know anything about them, so they're both X. And then when I go back and look at the problem, Jamie drove twice as far as Rhonda, so Jamie would be 2X. Now let's see if this makes sense. If Rhonda is the unknown and Jamie drove twice as far as that, then that's 2X. So X and 2X, twice as far, that makes sense. And now I can write out what this actually means, combined like terms. 2X and X is 3X. That equals the combined mileage of 90 miles. I'm going to divide both sides by 3. And X is equal to 30. Now, this is why it's very important to look at the context and what you're actually being asked. The question at the end of the problem says, how many miles did Jamie drive? But in our setup, Jamie is not represented by X. Rhonda is. So if I'm trying to answer the question, right, if Jamie is 2X, then that's 2 times 30. So Jamie actually drove 90 would be total. Jamie is 2X. 2 times 30 is 60. Oh, and I forgot to write drive in there. That's okay. Jamie drove 60 miles, or Jamie drove 60 miles. Okay. So remember that you have to always come back and look at the context of the problem, answer the question at the end. Jamie drove 60 miles would be how many miles of the 90 that they contributed. Okay, last example. Juan has a board that is 44 inches long. He wants to cut the board into 2 pieces so that one piece is 6 inches shorter than the other. How long will the shorter piece be? Okay, so again, this is a situation where we have 2 unknowns, or 2 pieces of wood being cut from this piece that's 44 inches long. So Juan has a board that's 44 inches long. That's a definite. We know that. He cuts the wood or the board into 2 pieces, so that one piece is 6 inches shorter than the other. Shorter is a subtraction, so we're going to subtract 6. How long will the shorter piece be? So we have 2 pieces of wood that we're adding together, and if you add the wood back together, it goes back to the original 44, right? You cut 2 pieces, they still would add up to the original 44 inches of the original bigger piece. So we have the long piece, and we have the short piece. The long piece is an unknown. The short piece is an unknown as well. Then we go back and we look at the problem. The shorter piece is 6 inches shorter than the long one. Okay, so I'm going to subtract 6 from that. So let's read and make sure this makes sense in context. So the long piece is X. The short piece is 6 inches shorter than that. So X take away 6. And together they equal the original 44 inches. Combine like terms, 2 X's minus 6 equals 44. We're going to add 6 to both sides. Okay, 2x comes down. The 6 cancels. 44 plus 6 is going to give us 50. Divide both sides by 2. And x equals 25. Okay. Now, again, context. We have to answer the question, how long will the shorter piece be? X does not represent the shorter piece. X actually represents the long piece. So if we want to answer the question, we take x, we subtract 6, and it gives us 19. So the short piece is 19 inches. Okay. And we have then answered the question, and so now we are all done. Okay, so with word problems, you always want to make sure that you read for context. You're reading to actually generate an equation. So you read through a couple times, underline the things you know, turn that into math, and then solve the equation.